Chapter 6, Data Analysis and Statistics. Like I mentioned in class last week, we're not doing 6.1 and 6.2 because that is reserved for pre-calculus. So we're going to do the first part of 6.3 today, which is use normal distribution. So what we're going to do in this video is just a very quick introduction of what normal distribution is and how you can make use of this information in preparation for your research project that you will do for the Chapter 6 test grade. So a normal distribution is the idea that the data you're collecting will fall in a shape, a curve that looks like a bell curve. You might have heard about people saying that's curve the test, or that college classes are graded on a bell-shaped curve. This is the explanation of why we use those words. So what are some of the data that actually falls into a normal distribution curve? A lot of things that happen by chance or just can go up or down are usually fall into that shape. For example, if you look at average people's height, let's say you have this scale, and this is, let's say, 180, 170, 160, 150. And people's height will, so you just do kind of a tally mark. You can expect that more people will fall. There'll be more people at the mean of the total, and as they get more, the taller and the extremely tall people and extremely short people are more rare. And the shape that I usually create is the bell curve. So that would be something like height of people, or how quickly someone can get to school. Let's say all the students coming from the dorm getting to school. Let's say the average is about 4 minutes, and some people walk really slow, so 8 minutes, and some people, I guess, instantly get there. So if you stand at the atrium and measure how fast people get there, the normal distribution model will assume that people get there in a bell shape. More higher percentage of people would be on the means, and the extremes would be fewer. Now, the model goes on to assume this relationship between the percentage and the standard deviation. So later on in this section, we will actually explain how to calculate the standard deviation. During the meantime, you just want to know how we actually apply and use it. So what this graph means is that if you take any data that you assume will follow the normal curve, then you take the mean, which is bar x, average of all the data, then you assume that one deviation away from the mean will contain about 68% of the data, and 2 deviation away will contain 95, and 3 deviation away will contain pretty much all of the data, so 99.7%. When you look at standardized tests like the Stanford 10 or SAT, whenever they give you a percentile rank, they're talking about this information here. So how many deviation away you are from the average grade. The information that we're going to use for today's homework, take this 68% and cut it in half, and basically tell you that 1 deviation away from the mean, this section will have 34% of the data of the entire curve. And 1 deviation down is also 34%, and as the deviation go farther away from the mean, the percentage that's under that curve is lower. Notice that this curve actually never touches 0. It's almost like an asymptote at 0. So you can actually have 10 deviation away. It's just that the percentage under the curve would be close to 0. So here is a kind of a mathematical example of what that would look like. So you can go to this website on your own on your computer and just kind of stare at it for a little bit, so you kind of get an idea what this animation is doing, the website is on the top. You have to type it in. You can click on this video. But the idea is that you have these pegs which are these green dots, and the pink ball is dropping off from the top, and they're exactly 50% chance to go left and 50% chance to go right. And as the ball falls down, it'll fall into these placeholders, and every time it falls down there, they tally it, and then it makes a shape. Notice that so far in the chart in the graph on the left, there are 33 balls already fall into the placeholders, and this doesn't look too much like a bell curve, because for something to be normally distributed, you need enough information, and we'll talk about this too later on in terms of population size and sample size, and how can we get a information that's actually reliable. The same animation, I left it running for a while and get to about 844 balls. Notice you can speed it forward if you're doing this on your own. You can see that the graph now fits more like a bell curve. So now if we apply the concept of normal distribution, we can make some assumptions. For example, let's say instead of 844, we actually run it to 100,000 balls. Then we can actually make this assumption, the conclusion that one deviation away from the mean will have 34% of the balls fall in that region, which is of 100,000. That means there will be 34,000 balls. And one deviation from both left and right, like we saw on the last page, will have 60. This would be 68% of the balls, which means 68,000 of the 100,000 ball will fall within this area. So that's one way we will apply normal distribution model to data that we're looking at. So let's look at an actual example from the guided practice. So in example 1, we are given a normal distribution with the mean x and the standard deviation. So the question asks, what if we randomly select an x value from the distribution? What is the probability that the x that we are looking for is higher than 2 deviation below and lower than the average? That means we want to know what is the chance that our x is higher than this point and lower than this point. So the math part is really simple. We just have to do 34%, which is the 1 deviation down, plus the 13.5%, which is the next deviation down, which is equal to 47.5%. That's our answer, which means in this normal distribution, the chance that we find an x that is between the average and 2 standard deviation down is 47.5%. So it's almost about half the chance that the number we randomly choose will be in that region. So here's the homework for tonight. You can start on it during the class time. When you're done, you can do something productive with your time. And tomorrow when I come in, we will finish part 2 of 6.3.